Video 8.1, day 2. We're still on variation functions. Please write down the essential question. How do I use inverse and combined variations to solve problems? A third type of variation describes a situation in which one quantity increases. Not mean to do that. So one quantity increases and the other decreases, thus an inverse relationship. One's up, the other one's down. Direct, they're both up or they're both down. For example, the table on the right shows that the time needed to drive 600 miles decreases as speed increases. So this kind of goes with what I said in the last video. I said it was the wording. The faster I drive, the quicker I will get to my destination. The way it's wording it here is, if I go 30 miles per hour, it's going to take me 20 hours. If I increase my speed to 40 miles per hour, then the time it's going to take me to reach my destination, I'm going to take 15 hours instead of 20. If I increase my speed even more to 50 miles per hour, it's going to take me 12 hours to get there. The distance is not changing. That's what we're talking about in inverse relationship, inverse variation. It can be written in the form y equals k times x. Y varies inversely. That's the key, inversely. Directly was y equals k times x. Now it's y equals k divided by x. Example number 1. Given that y varies inversely as x, gives us y, gives us x, and says, write the inverse variation and graph it. So here's the key, varies inversely, gives us y, gives us x. Varies inversely is that. Let's plug in what y is, let's plug in what x is, and we're going to solve for k. Well, how do we solve for k? Well, I can cross multiply, or I can multiply both sides by 5. So I get 20 equals k. So now I have y equals 20 over x. Now, this is a hyperbola. To graph this, the quickest way I graph this without a calculator is I just picked random x values. I picked 1, -1, 2, -2, 4, -4, and it's random. So 20 divided by 1 is 20. 20 divided by -1. 20 divided by 2 is 10. 20 divided by -2 is -10. 20 divided by 4 is 5. And 20 divided by -4 is -5. Plug in your x values and you'll get your y values. And when we plot these different points, we get something that looks, I'm just going to do a quick graph of this, something that looks like this, a hyperbola. There we go. Example 2 we're going to do in class, and we're going to go to example 3. The time t that it takes for a group of volunteers to construct a house varies inversely. So I'm going to highlight this as I go. Varies inversely. And time varies inversely as the number of volunteers v. I'm going to just write my equation right away. Time, whoops. Instead of y and x, I'm going to use t for time. Time varies inversely. I'm going to write t equals k. Inversely means over v. Because directly, it would be k times v. They're telling us there's 20 volunteers, so I know v is 20 that can build a house, and I know my time it's going to take to build the house is 62.5 hours. How many working hours would it take if we used 15 volunteers? Well, the first thing we need to do is we need to solve for k. Remember, these are 2 steps. So I plug in what t is. I don't know k, and I plug in what v is, and I'm solving for k. Multiply both sides by 20. 20 times 62.5 is 1,250, and that's our k value. So now our equation is going to be, we're going to kind of go like this and like that. T is equal to k for v. And now I'm going to answer the question. We're going to use this inverse relationship to determine how many hours is it going to take to build a house with 15 volunteers. So I'm solving for t. I know that this time v is going to equal 15, so I plug that in, and 1250 divided by 15 is 83.3 hours. And that is my answer. So let's think about this a minute. Does this make sense? Sure it does. If I have 20 volunteers versus 15, I'm going to build my house a lot quicker. It's going to take 62.5 hours. 15 volunteers, less workers working, it's going to take longer to build the house. So that's an inverse relationship. You can use algebra to rewrite variation functions in terms of k. So that's what we're going to talk about next. So we know a direct variation is y equals k times x. So if I say solve for k, we divide both sides by x. And this is what we get. If it's an inverse variation, that's y equals k over x. To solve for k, we multiply both sides by x, and we get k equals x times y. So if we're trying to determine, if you're given a table of x's and y values, and you're trying to determine if it's a direct variation or inverse variation, well, we're going to look at the ratio of y over x and the product of x times y. Whichever one is constant, then that's what we choose. If neither of them are constant, then it's neither. Notice that in direct variation, the ratio of the two quantities is constant. In inverse variation, the product of the two quantities is constant. Here we go. And I wrote some stuff ahead of time. So I'm giving you 3 different tables of x's and y values. And what I did over here on the left is exactly what we talked about right here. So determine whether each data set represents a direct variation, an inverse variation, or neither. So what I need to do, if it's a direct variation, the ratio of y divided by x is constant. If it's inverse, the product of x times y is constant. So let's first look at the ratio. So if I take 8 divided by 6.5, I get 1.23. If I take 4 divided by 13, I get 0.31. They're not the same. So it's not direct for sure. So now let's look at the product. Well, 8 times 6.5 is 52. 13 times 4 is 52. And 104 times 0.5 is 52. So because go. The product is constant. We're going to call A an inverse variation. The product is constant, it's inverse. So we will write this is an inverse variation. Let's go down to B. All right, again, I'm going to look at the ratio of y over x and then the product. So 30 divided by 5 is 6. 48 divided by 8 is 6, and 72 divided by 12 is 6. So I don't even have to look at the product at all. because if it works where the ratio of y divided by x is constant, I'm done. Because you can't have both a direct and an inverse variation. It's one or the other. In this case, because our ratio of y divided by x is constant, that is going to be a direct variation. So B is a direct variation. Let's look at C. Again, do the same thing. 5 divided by 3 is 1.7. 14 divided by 6 is 2.3. I don't even have to look at 21 divided by 8 because these are not the same. So I know for sure it's not a direct variation because the ratio of y over x is not constant. So now let's look at the product, x times y. 3 times 5 is 15. 6 times 14 is 84. These are not the same. I don't even have to look at 8 times 21 because since my ratio of y over x is not constant and my product is not constant, that means C is neither. It is not a direct or an inverse variation. Example 5 we're going to do in class. And now I'm going to go to 6. And on 6, we're talking about a combined variation. Oops. That is a relationship that contains both direct and inverse variations. It's kind of like joint variation in the last video. Quantities that vary directly appear in the numerator, and quantities that vary inversely appear in the denominator. It's as basic as that. All right, so here we go. Grab my highlighter. So the volume V of a gas varies inversely. What does it vary inversely as? The pressure. Okay, so I'm going to do little baby steps. Volume. It's always whatever we're talking about. Volume, time, whatever. It's always going to be the variable equals K, whether it's varying inversely or directly. Now, what does it vary inversely as? Pressure. Inversely means the P goes in the denominator. And now I keep reading. It varies directly with temperature or as temperature. So I know T goes on top. Anything that volume varies directly with goes in the numerator. Anything it varies inversely with goes in the denominator. And K is always in the numerator, I'm going to call it. Okay, so they're telling us that a certain gas has a volume, a volume of 10 liters, a temperature, that's our T, of 300 kelvins. That's not our K value, that's our temperature, and a pressure P of 1.5. Let's plug all those items in to find K, our constant of variation. And when I do that, I can multiply both sides by 1.5. So I get 15 is equal to 300K. Divide by 300. 15 divided by 300 is 0.05, and that is our K value. All right, so now we have V equals KT over P. Remember, now we plug it in, and we don't plug in what T and P are yet because we have to read the question and see what we're going to do next. We have already used, let's talk about what we've used. We've used 10, 300, and 1.5. 10, 300, and 1.5. We've already used those. Can't use those again. Now, if the gas is heated to that 400K, that's our temperature, has a pressure of 1, now What's its volume? So we know T is 400. We know P is 1, and we need to find volume. So let's plug it into that equation. So we have V equals 0.05 times T divided by P. Well, 0.05 times 400 is 20. And in this case, our units is liters. And there is our answer to our question. We just used combined variation. Read these video questions. Write the inverse variation function. Determine whether each data set represents a direct variation, an inverse variation, or neither. And that's it.